Hello from West Virginia! Eventually. So I've got a joke of the day and I know that you are ready and waiting for it. How do you get down off an elephant? You don't get down off an elephant, you get down off a goose. You silly goose. Okay, but what is not silly is the quotient rule for square roots. So let's take a look at this. Now recall your product rule for square roots. Your quotient rule is going to be very similar to that. Notice what we have here is two problems that look very similar. However, the order in which you're going to do those operations is different, and that may or may not cause different results. Remember when there was a plus sign in there, and we had, say for instance, like 100 plus 25, or square root of 100 plus the square root of 25, that created different results. But in our product rule, we discovered that when it was like 100 times 25, or square root of 100 times the square root of 25, that created similar results. So let's take a look at this one. In this first case, we know that we're going to take 100 and divide it by 25 first, and that will give us 4, so we'll have square root of 4, which is just 2. But in the second one, it says let's do the square root of 100 first, which is 10, do the square root of 25 next, which is 5, which again gives us 2. So just like that product rule that said if I take the individual roots and then multiply, or if I multiply and then take the root of that, I'm going to get the same answer either way. Your quotient rule for square roots essentially says the same thing. So your quotient rule for square roots says for all numbers that are greater than or equal to 0, once again like that product rule, we can't use any negative numbers, and 0 itself is okay. And those numbers are going to be real numbers, and again that leaves out complex numbers, which we're not even talking about right now. But what that quotient rule says, I can either do the division first and then take the square root, or I can take the square root of the numerator, square root of the denominator, and then do the division. Either way I'm going to get the same answer. Here again is the pan balance idea. Fulcrum in the middle, and this is what's in this pan. This is what's in this pan. It's all balanced out, meaning they have the same value. So this or this, either order of the operations, I will get the same result as we saw up here. And just like with that product rule, this is helpful for simplifying radicals. And remember, you know that you are done simplifying a radical when that square root has no perfect squares underneath the radical. And remember, perfect squares are numbers that you can take the square root of. In addition, there are no pairs underneath the radical. And we saw, as we saw before in the previous video with your product rule, pairs create perfect squares. And so that's why you don't want to have any pairs underneath the radical, because that means you still have perfect squares underneath the radical. So what we had seen before in that product rule was if you saw a perfect square underneath the radical, you take the square root of that number and take that out of the radical. If you see a pair, you take one out and it dissolves the other one. Because again, those two numbers will create a perfect square, and you'll take that square root out. So if you see that pair, because they create a perfect square, just go ahead and take one out and it dissolves the other one. It's not magic, it's math. So let's take a look at these three examples utilizing that quotient rule. Notice in this example, according to what I see, I would take the 49, I would divide it by 64 first. But if I do that, I'm going to get some crazy messed up decimal, and I'm going to try to take the square root of that crazy messed up decimal. I can't do that in my head. But this is where my quotient rule is so helpful. Remember, the quotient rule says I can do that division first and then take the square root, or I could take the square root of the numerator and the square root of the denominator, and then I could do the division. Because I do know the square root of 49, what would I multiply by itself to create a 49? That would be a 7. Now remember, we talked before about that this could be a positive 7 or a negative 7, because negative 7 times itself, negative 7 will give me a positive 49. But this is principal square root, right? Actually, it's negative square root. But ignoring that part and just dealing with this part, I'm dealing with principal square root right there. So I'm just dealing with the 7. Now here, the square root of 64, what would I multiply by itself to create a 64? That would be an 8. Simplify a fraction if you can. That won't simplify, so I know that it's done. And I don't have any perfect squares or pairs underneath the radical. Here is a beautiful example of where that quotient rule is so helpful. So now let's take a look at the next one. I could take the square root of 96x on that numerator and then take the square root of 8x and then do the division. And can you think of a number that you can multiply by itself to create an 8? No. Can you think of a number you can multiply by itself to create a 96? No. So maybe what would be better would be to use that quotient rule and put them together like this, because 96 divided by 8 is going to give me a 12. More importantly, though, what's going to happen to these x's? Yes, the x's will cancel out completely. Beautiful. Because now all I have to do is simplify this square root of 12. Once again, looking for perfect squares or pairs. Because, can you think of a number that you can multiply by itself to create a 12? Nope. So let's break down. Let's break down that 12. 12 is going to be 4 times 3. And I do know the square root of 4. The square root of 4 is 2. So I'm going to take its square root out. And when I take the square root of 4 out as 2, I'm left with 3 underneath. Simplified, because I can't think of a number that I can multiply by itself to create a 3. And that 3 won't break down into anything useful. It only breaks down as a 3 and a 1. That doesn't help at all. All right, last one here. So once again, I can take the square root of 100, x to the 4th, which, hey, wait a minute. I do know the square root of 100. That's 10. And I do know the square root of x to the 4th, because what would I multiply by itself to create x to the 4th? That would be x squared. But notice what happens here. I am left with this radical underneath the denominator, and that's not okay. Now, much later, in a later video, I'll show you how to get a radical out of the denominator. But for right now, that's not okay at all. So instead of this, what I'm going to do is go ahead and employ that quotient rule, and I'm going to put them together underneath one big radical, because now what I'm going to do is I'm going to say 100 divided by 5 is 20. I can deal with this. And I'm going to say x to the 4th divided by x to the 1st. Remember those laws of exponents. The laws of exponents say I'm going to subtract those exponents. 4 minus 1 will give me a 3, and I have x to the 3rd. Now, can you think of a number that you can multiply by itself to create a 20? Nope, I can't either. So what I'm going to do then is I'm going to take that 20 and I'm going to break it down. 20 is going to be 4 times 5. And I do, once again, know that the square root of 4 is 2, so I'm going to take that 2 out. Now this x to the 3rd, let me go ahead and take that 2 out. Now this x to the 3rd here, I know that it is x squared times x. According to those laws of exponents, I'm going to add these two up, and that'll give me x to the 3rd. The reason I did that is because, oh, okay, I know what I can multiply by itself to create an x squared. That would be x times x. So what I have then is x outside along with the 2, 5 and x underneath, and there's nothing more that I can do with that, because I cannot think of a number that I can multiply by itself to create a 5, and I can't break that 5 up into anything useful. So it is done. I hope that helps with your quotient rule and being able to simplify your radicals. Like I said before, simplifying those radicals, you know you are done when you have no perfect squares underneath the radical and when you have no pairs underneath the radical. And the quotient rule says I can either do the division and then take the square root, or I can take the square root of the numerator, square the denominator, and then do the division. I hope that helps. Have a great day.